I'm Kimball Johnson. I work for Chef Software as a developer advocate. I'm going to talk to you about Inspec. The title of my talk is Inspec, One Tool to Rule Them All, because I want to talk about not just like what people would traditionally know as Inspec for, as a testing tool or a sort of a basic compliance tool to understand like the state of your infrastructure. I want to talk about how much further you can go to that. But in order to do that, I'm going to start from a much earlier stage. I just wanted to talk a little bit myself. Like I've had a lifetime in tech. I've been using technology since I was about 4 or 5 years old. My dad happened to have like a ZX Spectrum, which I was programming on from an early age. I had the opportunity at school with BBC Micros and Macs. I had robotics and stuff. And all the time, I've always worked on things to make automation stuff, because essentially I'm quite lazy, and I see automation as the way to be professionally lazy. And also in my free time I have a lot of other interests, particularly Minecraft, which we'll come to later. So, why do we test? That picture there is of a chemistry test lab, but I want to talk a little bit about why we test. This might seem very, very obvious. A lot of people think, oh, test to make sure everything's working. But why we test is a lot more complicated, a lot deeper than that. We need to understand like what it is that we're testing for, the purposes that we're seeking to achieve from that, and what have you. I found this nice quote here of what software testing is all about. We're talking about an investigation conducted to provide stakeholders with information about the quality of the software product or service under test. This is for Sem Kainer in a presentation that he gave a number of years ago. And it's really interesting, this definition, because it starts to deep down on what we're doing it. When we're not necessarily just testing for ourselves, we're testing for other people. What we are wanting to understand. We need to understand what the software is doing. We need to understand what we expect in the software to do and whether it's still doing it. We need to make sure that we're providing the information that all the various different stakeholders have. And this is one of the things I think is particularly important, is with the different stakeholders. Because we can run our tests, so yes, we know we've got this specification and the code works to how we expect it. But there's other stakeholders involved in that. There's the stakeholders of security, there's the stakeholders of the user interface. There's stakeholders who may not necessarily understand what your tests are doing, and they need to have more context around them. So one of the things that I think makes Inspec really good for this as a testing tool is the way that it's designed, and it's not the first to do it, but the way it's designed to be much more human readable. Take, for example, oh sorry, I've gone off track. I want to talk a little bit about the reasons for testing. We want to validate the assumptions. We want to make sure that what we think is the state of our system truly is the state of our system. This one is one that comes up a lot. Often people will say, for example, they believe that all of their systems will always have a shell on there and it's always going to be bash shell. And then Debian goes and changes the default shell to dash for /bin/sh, and that's an assumption that people have broken. Now, if you had proper testing in place, you would be able to ensure that the shell is really what you want it to be. Now, this is a contrite example, just because it's something that I know affected a lot of people. But it's important to think about that in terms of your assumptions, making sure you're validating the assumptions so that you're getting the right sort of achievement out of it. Highlighting regressions, again, sometimes regressions happen not because of anything that you didn't change anything in terms of the code that was for a particular feature, but an unexpected occurrence as a result of what you've done. You don't necessarily think about this in advance, and you don't even necessarily particularly care about that yourself, but other stakeholders may do. And so by ensuring that the tests are in place, especially when we're talking about automated tests, the testing means that those regressions will be highlighted even if it's not something that you will be thinking about. Consistency as well. This is a reason for using testing tools and automated testing. You want to make sure that every time you run your tests, you're getting the same result. You're getting the same setup. You don't want to have people that are testing, like, if you take manual testing, different people are going to think about different things, and a whole load of stuff will get missed, and that's no good. So that's another reason why we do the testing in a structured manner, to ensure consistency. And this one I think is a really important one. A lot of people will want to, we talk about deploying. We just had a talk about how we can deploy, 20 times a day. You can only get to that state if you've reduced the friction of the testing so that it's reliable enough and easy enough to do that you will test and you will be happy and you can convince everybody that that kind of release cycle makes sense and is doable. And you don't necessarily want to be able to release 20 times a day. You don't necessarily want to have any of that kind of stuff, but you do want to make sure that when you have all this testing framework that exists, it's as easy to use as possible, it's easy to update as possible, and as easy to understand as possible. So I thought I'd show a little bit of an example of the Inspec code, because these are things that the design of the Inspec code is such that no matter if you've got any kind of basic understanding, these tests should be easy to understand. And this is really key about the design of Inspec, is that we want to make sure that people are able to understand the code that's going on without being locked down in complexity of regular expressions or obscure command line arguments and what have you. So we've got things like here. We're saying very simple, a file should exist. And it's very easy. We're describing a file and saying it should exist. We're looking at an Apache configuration. Now, Apache configuration is an unusual configuration style compared to a lot of other configuration style. But we're just saying here, find the listen argument in it. And that's the depth of that is all hidden away in the implementation of Inspec so that your test is very, very simple. And then, of course, we can test other things like port 8080 should be listening. So, we've determined why we're testing. We want to make sure that it's as easy as possible, that we're wanting to ensure that the assumptions are all validated, that there is reducing friction. But that's kind of really just talking about software testing. But software testing is a relatively small part of the puzzle when it comes to the whole world of software implementation. And another part of it is compliance and audit. Now, what's the difference between compliance testing and audit testing? Well, compliance, according to the Cambridge English Dictionary, is the fact of obeying a particular law or rule or of acting according to an agreement. And a particular of note of here is talking about agreements and rules. This is going to very clearly be introducing a much wider set of stakeholders, especially in this case. Now when we're talking about laws and rules that are outside of the realm of the software itself, we're definitely going to be talking about stakeholders who aren't necessarily familiar with code. Even the relatively simple code of Inspec, that alone isn't necessarily going to be understandable by all these stakeholders. Additionally, a test, for example, that port 80 is blocked. Why? What does that mean? We need to have more around that. We need to have metadata so that we understand why these rules, why these tests are in place. What are they referring to? What rules are we doing? So here is the extension of Inspec, including the whole compliance controls. And we've still got the test there. We're saying SSHD config, its port should be 22. It's a fairly simple test. That's relatively easy to understand. But what we're talking about here is ensuring for all these different reasons and putting the context around this at why we want the test to be as it is. So we have the impact score. We're saying there's a particular level of risk around this not being correct. So we need to determine that. We have some titles and descriptions. This is fairly self-explanatory. We're wanting to allow to understand what we're doing, why we're doing this. And part of this is in the Chef Automate system, it allows you to, the metadata is interpreted in certain ways. So the rationale bit there gives us like a subtext for a title when you were looking at this control, so you can understand what's going on. We've got tags for easy searching. We're also tagging, particular a CCE value of things, all these different things, so you can search and find everything about SSHD or everything about OpenSSH and be able to find all this stuff. And then importantly, and this is particularly important when we're talking about compliance audits, we have a reference to why this particular rule is in place and where it's from. We're saying here that this is for referencing to this NSA standard of having of how Red Hat systems should be set up, and saying that the SSH config should always be on port 22, and the reasons that are given in the document. So anybody that's not within the realms of software and what have you, they can look up that document, they can understand, okay, there's a test here, they can be, maybe they even come and referring from that in the first place, and they're able to be sure that if you're running this test, you're doing it for the reasons that they expect, and they're then happy with their system. And of course, we can show all of this stuff up in the Chef Automate server, so you can see very easily there's critical failures here, and there's non-critical. There's critical failures, there's critical successes. It's all very easy. You can see the audit trail and what have you. So now we've determined we've got a nice system. We can use it for software testing and we can use it for compliance. This in itself is great. But Inspec is a modular, very pluggable system. You can define your own rules. Now, I talked earlier before about how Inspec was designed so that it was, so that anything you were describing, like that describe Apache port, was easy to read and understand. And so part of what we do that is, say you have some kind of particular type of configuration file in on your system that's not used anywhere else, and you've got a great parser in it for your system and whatever is fine, but you want to be able to write a rule that says this particular setting should equal this setting when we're running the tests. You don't want to have a regular expression or some complicated source code or anything in the middle of your test things. You want it to just read nicely and easily along with all that rest of that metadata so people understand what's going on. And so Inspec provides the ability to write custom resources to allow you to test or define a test for however what you want. And these, again, these are designed to be very, very simple, and the existence of these has spawned huge levels of extensions to Inspec, way beyond what the original authors even thought of. So I thought I'd show you a little bit about how simple this really is. This is going to allow you to test, to be able to validate and run tests on a JSON file. Now, the reason that what I really like about this is that we have this initialize statement. It loads up the JSON file. And we set up these, we then put all these parameters as such in there. There's also another part that's missing from this, for this example. You can also then just parse that, you can parse that JSON file. I missed it off a slide, it's very annoying. You parse that JSON file into that param structure. And then we take advantage of some of the meta-programming parts of Ruby to say that any method that doesn't exist, we use this method, it goes to this method missing example. And that essentially means that for every parameter that was inside that config file, we're now able to refer to as a refer to in the Inspec code as something that we can check against. So no matter what you have in there, if there's a parameter, say, Fred, in there, even though we haven't defined a particular check for Fred. The way Inspec works and the way the system works means that we can define and run checks for Fred. Or, you know, version. So we're now saying here, the version number that's inside this config should be equal to 2.0. And that would just be defined by the fact the JSON would have a JSON object at the top of the name version value 2.0. And if that existed, this test would pass, and it's very, very simple. So okay, so we can write custom resources, so we can describe anything that we can think of. Well, let's take an example of somewhere where there's been some very high value security breaches, where the testing seems maybe relatively easy, but has in many cases not happened. And that, of course, is the cloud. And this particular cloud with the lightning bolt, because it really can be quite severe when things go wrong. So I found a few examples. This was just searching on my train over here. Dow Jones in July 2017, 2.2 million records of personal information were leaked due to a misconfigured S3 bucket. Accenture, October 2017, 40,000 passwords, encryption keys, and even their API keys for their production AWS account were all just sitting in an S3 bucket. Alteryx, December 2011, the PII of 123 million households in America. There's only about 125 million households in America, so that's basically entirety of American citizenship was compromised by a misconfigured S3 bucket. And I really wanted to find something that wasn't just S3. So I found this one in Perva, October 2018. Actually dates back to October to 2017 was when the breach was first implemented. The mistake that made the breach was first 2017. And that was a misconfigured RDS that in turn held an AWS key. So an old RDS backup was found from a clone of an RDS with weak securities, which in turn had an API key that had been sitting, languishing, and still active for a year. And that then caused another major outage. So we should be able to test this. Now we've talked about the extensibility and what have you. And so with Inspec, we can define some very simple rules. For example, a user should have MFA and not have any access keys connected to their account. A security group should have certain ports allowed. We're allowing port 22 in from our IP address range, but not just from the world. Our S3 bucket should not be public. And these are very simple to understand. You can run these against the AWS API, such that you can scan your entire account very, very quickly, get the listing of all of your S3 buckets, make sure they're not public, or set up exceptions. Something I've not covered in this, but Inspec allows you to set up exceptions saying, okay, this particular system is allowed to have that open for this reason. This is the ticket number that approves it, etc. Even with time limits. So, well, I've shown Inspec running before, and I'm sure you probably realize Inspec can connect over SSH, but this is a cloud infrastructure. This is a little bit different. And there's lots of different clouds. We support Amazon, AWS, we support Azure, we support Google Cloud, we support DigitalOcean. And so all of these have different ways of accessing. So just being able to create custom resources is not really enough. So there's another aspect of Inspec, and that's its full pluggable system. To really make it the full Swiss Army knife of tools. So we can write plugins for adding additional commands to Inspec. A really interesting one of these has been written by one of our engineers in Australia is the ability to take a Terraform file and create a set of Inspec rules to validate that the Terraform file is applied correctly. You can extend the DSL in a very way. So the tests that we've shown before were all, okay, these are a bunch of individual tests. But you can extend the DSL in any section. So you could, for example, write a set of tests where you want 2 out of the 5 tests to pass, and you consider that a pass for whatever reason. It's incredibly extensible. But the big one here is the platform connectivity. The ability to write using the underlying transport layer, which is train, the ability to create plugins to support SSH, WinRM, various different cloud infrastructures, and what have you. This is an example of creating a plugin to add a CLI command. It's, again, very, very basic understanding. We define a class that is dependent on the Inspec plugin class. And then we say my CLI command is my command, and then when that runs, it's going to just run the code in that CLI command function class, which can just be something very, very simple. Again, the whole infrastructure is designed very simple, so you can build out whatever you want. Existing plugins, we've got the ability to the Chef and the Vault ones here. This is one of the things that Inspec allows you is to bring inputs in so that you can base your checks around external inputs. One of them being HashiCorp Vault, for example. If you're needing to do tests that are going to rely on secret data, the Inspec Vault plugin will allow you to be able to access that secret data as part of your test suite, so you're not hard coding secrets into your tests. Inspec Iggy there is the one I talked about, being able to create an Inspec profile based on a Terraform profile. And then the train, these are all of the train plugins that have been published onto Ruby Gems. We can talk to WinRM, we can talk to PuppyDB, we can talk to Kubernetes, we can talk to Habitat. And these, again, they're relatively simple. I was looking through the code again. They're not quite as simple. The connection plugins aren't quite as simple as the other plugin architectures, but again, the whole system is designed to be very simple and easy to use. And to show the power of what you can do with it, I've got a little demo that I've prepared. So I'm just going to get a couple of things set up and just demonstrate my demo. I don't know how to get out full screen. There we go. So over here, so here we have Minecraft. And there's a little house there that isn't necessarily very safe. Mobs can spawn in it if it wasn't in peaceful mode. So we can run this inspec exec command, and you can see, yeah, it's not safe. So I'm going to have to put the microphone down for this. So I'm going to go in, I'm going to put some torches up in this house. The blue light there is not real light as far as Minecraft's concerned, it's just so we can see it. So now that house has now got torches in it, so we're pretty happy we can run our tests. And we'll run it again, and we'll see, is this house mob safe? And we see, yes, it is. Now I'm going to show you the Inspec profile for that. It's literally that. It should be describe Minecraft, it should be mod safe. Now obviously I've written a custom resource for that to be able to implement it, and I will, when I've fully filmed this out, we'll put it all up on GitHub, so you can see where everything goes on around that. But I thought if I demonstrated that if you can validate Minecraft with Inspec, I figure you can validate anything with Inspec. The way that's done is with a Minecraft plugin that allows everything to be presented over a REST interface about the surroundings. But you can do, obviously, we saw on there was an Inspec train plugin for serial. So if you've got something that you can access over serial, you can define it that way. And so I'm a little bit quick on time, but that's the course of my presentation. So one thing I want to add is that everything that I have shown you is open source. Although the binaries that you get from Chef themselves, you have to pay for commercial license for. Inspec is built under the Sync project as Sync Audit as a free distribution as well. And so it's all open source. Automate is open source, although there's no free distribution of it yet, but there is going to be in the future. So obviously, while I'd like you to give money to keep me in a job, you are able to use all of this as open source and free as well. Thank you. Any questions? Yes?
Can you go a bit further on the Terraform integration?
So the question was, can I go a bit further on the Terraform integration? And I'm afraid I can't. I've never actually looked at Inspec to see what it does. But the idea is, from what I understand, Matt Ray was the author of it, is that you can scan, it will read your Terraform file, or possibly the Terraform state file, I'm not sure which of the two, and then build out a set of the rules using the various cloud plugins to define what the state should be. So then you can run those tests as part of your compliance, or you can tweak them if you know that, if you can look through those tests and go, well, actually, this is what I want the state to be in the future, and then I can run those tests, so when I make the changes to my Terraform file, I can validate that it is what I expect it to be. I don't think the idea is that you continuously just rerun the Inspec it builds you out a profile so you can then work on that in the future. Any other questions? Okay, thank you very much.